Could a plant-derived compound revolutionize breast cancer treatment as we know it? It's a question that has been sparking intrigue and excitement in the world of medical research. The answer lies in a compound known as artemisinin, a derivative of the Artemisia annua plant, also known as sweet wormwood. Originally hailing from traditional Chinese medicine, artemisinin has long been recognized for its potent anti-malarial properties. But recent studies suggest that this miraculous compound may hold the key to a new frontier in breast cancer treatment. Armed with the potential to inhibit tumor growth, induce apoptosis, and even eliminate cancer stem cells, artemisinin is fast becoming a beacon of hope in the fight against breast cancer. So, how does this humble plant derivative promise to change the game in one of the most widely researched and deeply personal medical battles of our time? Let's dive into the research that explores artemisinin's potential in tackling breast cancer. Our first stop is a study that explores how artemisinin may induce apoptosis in breast cancer cells. Stepping into the world of research, we find ourselves examining a study that delves into the potential of artemisinin, a compound derived from the plant Artemisia annua. This study casts a spotlight on artemisinin and its semi-synthetic derivatives, collectively known as ARTs. These compounds are well known for their anti-malarial properties but have recently taken center stage for a different reason: their potential anti-cancer effects. The study reveals that ARTs may work through a variety of mechanisms to fight cancer. These include the production of reactive oxygen species, cell cycle inhibition, and most significantly for our discussion today, apoptosis induction. But what does this mean? Essentially, apoptosis is a form of programmed cell death. It's a natural process that helps maintain the balance of cells in our bodies. When a cell experiences irreparable damage, apoptosis is triggered to ensure the faulty cell doesn't multiply and cause harm. However, cancer cells have a knack for evading apoptosis, enabling them to proliferate uncontrollably. Here's where ARTs come into play. The study suggests that artemisinin and its derivatives may induce apoptosis in cancer cells, effectively causing these rogue cells to self-destruct. This makes ARTs a potential asset in the fight against cancer, including breast cancer. But that's not all. Alongside apoptosis induction, the study also indicates that ARTs may inhibit angiogenesis, the process through which new blood vessels form. By doing so, they could potentially starve tumors of the nutrients they need to grow. Safety studies of ARTs have shown low toxicity and minimal adverse effects, further highlighting their potential as a cancer therapy. In essence, this study paints a promising picture of artemisinin's potential to trigger cell death in breast cancer, opening up new avenues for exploration in the battle against this pervasive disease. Next, we delve into a study that investigates how artemisinin disrupts key signaling pathways in breast cancer cells. This research, conducted at the University of Washington, takes a step towards a novel approach in breast cancer treatment, utilizing pH-responsive artemisinin dimers for liposomal nanoparticle formulations. The synthesized artemisinin dimers demonstrated potent anti-proliferative activities against breast cancer cells. How did they achieve this? By downregulating key proteins involved in cancer progression. This is a significant finding as it means that artemisinin can disrupt the mechanisms that allow cancer cells to multiply and spread, potentially halting the disease in its tracks. Artemisinin, a natural product used in malaria treatment, has shown promising anti-cancer effects due to its ability to target cancer cells with elevated iron uptake. However, the study acknowledges challenges such as poor solubility and rapid clearance from circulation that need to be addressed for further clinical development. To overcome these hurdles, the researchers explored the use of liposomal nanoparticles as drug carriers. This approach aims to improve the bioavailability of the drug and its delivery to target sites, enhancing its therapeutic potential. The synthesized artemisinin dimers showed improved cell proliferation inhibition effects compared to known derivatives, making them potential candidates for cancer therapy. So, what does this mean for the future of breast cancer treatment? It suggests that artemisinin and its derivatives could play a crucial role in disrupting key pathways that allow breast cancer to progress. By targeting these pathways, artemisinin could potentially halt the growth and spread of the disease, offering a new direction in breast cancer treatment. This research further underscores artemisinin's potential as a powerful weapon against breast cancer. Our journey continues with a study that looks at how artemisinin may inhibit angiogenesis in breast tumors. Angiogenesis, the process through which new blood vessels form, plays a crucial role in tumor growth and survival. Tumors need a blood supply to grow and spread, making angiogenesis a prime target in cancer treatment. Now let's dive into a study that explores how artemisinin, a compound derived from the sweet wormwood plant, may tackle this process. The research conducted on MCF7 cells, a human breast cancer cell line expressing estrogen receptors, sheds light on artemisinin's anti-proliferative effects. The study indicates that artemisinin disrupts the estrogen-stimulated cell cycle progression in these cells. Intriguingly, it appears to selectively down-regulate ERA expression without affecting ERB, leading to a shift from a high ERA-ERB ratio to a state where ERB predominates. This shift is associated with the anti-proliferative effects of artemisinin, hinting at its potential to inhibit the growth of breast cancer cells. But how does this relate to angiogenesis? Well, by disrupting the cell cycle progression, artemisinin could potentially inhibit the growth and division of endothelial cells, which are integral to the formation of blood vessels. This could, in essence, starve the tumor of its essential nutrients and oxygen supply, thereby inhibiting its growth and spread. Finally, we explore a study that investigates how artemisinins may selectively eliminate cancer stem cells within breast tumors. These stem cells are often likened to the roots of the cancer, as they are responsible for the initiation, growth, and recurrence of tumors. The study we are looking at is titled Artemisinins in Cancer Therapy, a promising agent for targeting cancer stem cells. It presents an intriguing perspective on the role of artemisinin and its derivatives in combating cancer by targeting these stem cells. In this research, artemisinin and its derivatives have been identified as potential agents capable of targeting cancer stem cells. These compounds, derived from the sweet wormwood plant, are known for their anti-malarial properties. However, their potential as anti-cancer agents is currently under exploration. The study highlights the various ways in which artemisinin interacts with cancer stem cells. It suggests that artemisinin and its derivatives can inhibit the self-renewal capacity of these cells, impeding their ability to initiate and sustain tumor growth. Furthermore, the research provides insights into the mechanisms by which artemisinin achieves this. It appears to induce apoptosis, a process of programmed cell death, in these cancer stem cells. This essentially means that artemisinin can trigger these cells to self-destruct, thereby preventing the growth and spread of the tumor. Moreover, the study notes that artemisinin and its derivatives have shown low toxicity and minimal adverse effects, making them promising candidates for cancer therapy. This research reveals the exciting potential of artemisinins to target the very roots of breast cancer. It's a promising development in the field of cancer research and opens avenues for further exploration of artemisinin and its derivatives as potential anti-cancer therapies. As we journey through the landscape of artemisinin research, we witness its potential to reshape breast cancer treatment. From inducing apoptosis in breast cancer cells to disrupting key signaling pathways, artemisinin and its derivatives have shown promising anti-cancer properties. Furthermore, the ability of artemisinin to inhibit angiogenesis in breast tumors, coupled with its potential to selectively eliminate cancer stem cells, paints a hopeful future for this natural compound in the fight against breast cancer. The profound impact of artemisinin, however, is not just limited to its direct actions on cancer cells. By enhancing drug bioavailability and delivery to target sites, artemisinin could play a pivotal role in overcoming challenges such as poor solubility and rapid clearance from circulation, issues that have long plagued the field of cancer therapeutics. While there are still many hurdles to overcome, the promising results from these studies have ignited a spark of hope. They have laid the foundation for a future where artemisinin, a humble compound derived from the sweet wormwood plant, could potentially revolutionize the treatment paradigms of breast cancer. Stay tuned for more enlightening explorations into the world of breast cancer research as we continue to uncover new hope and possibilities.